You may remember from previous chapters that covalent bonds form from electrons being shared between two atoms. Actually, that sharing can be unequal. And if you have siblings or kids, you know all about unequal sharing. And we're going to look at a measure of the sharing known as electronegativity. So first, let's look at this graphic here. We have on the left-hand side a molecular model of the hydrogen molecule, two hydrogen atoms sharing two electrons, as well as a molecule of hydrogen fluoride. In the hydrogen atom, each nuclear charge of the hydrogen atom, the nuclear charge of each hydrogen atom is the same, +1, and the two electrons are equally shared. So when electrons are equally shared, that's known as nonpolar. Everything's equal. Now, if we look at the bond, the two electrons that are being shared between hydrogen and fluorine, hydrogen has a nuclear charge of +1, whereas fluorine has a nuclear charge of +9. That's way higher than +1. Fluorine is able to pull the electrons toward it and unequally shares. Poor little hydrogen is left with much less of the two electrons than fluorine is. And that's known as a polar bond, where there's a separation of charge due to electrons being more attracted to one atom than the other. Now, the way that we typically signify this is through this Greek letter delta. And the fluorine, because it pulls electrons towards it, has a partial negative charge, whereas hydrogen, since it's losing those electrons to fluorine, has a partial positive. Remember, electrons have a negative charge, so if something has more electrons, it's going to have a negative charge. Less electrons, a positive charge. Another way we can signify a polarity of a bond is through this arrow. The arrow always points to the atom that pulls the electrons toward it, and then there's also a little vertical line that looks like a positive sign from the atom that will have the partial positive charge because it's losing electrons towards the other. When we have the separation of charge due to this unequal sharing of bonding electrons in a bond, that's what's known as a dipole. And a dipole is just a separation of charge. Now, the attraction of bonding electrons to one atom over another to form polar bonds, or a dipole, is actually way more complex than just looking at the nuclear charge, although that's part of it. So what we have instead is this table known as electronegativity values. And what electronegativity does is it is a measure of the ability of an atom in a bond to attract shared bonding electrons toward itself. And the higher this number, the better able that atom is to pull electrons toward itself. Now, there is a trend on the periodic table as we go from left to right. Electronegativity increases across the period, and as we go from the bottom of a family or group or column up, it also increases. But you'll always have this table, so you won't have to memorize any electronegativity values.